My name is Wasim Asghar. I'm a licensed professional engineer in the US and Canada. I help students prepare for IP electrical and PE power exams, which they need to pass in order to become a licensed professional engineer in the US. Some of my students are actually working in research and development. Some of my students work in labs. Others work in equipment testing. Research and development, especially when it comes to different types of materials, is essential to innovation in power systems industry. Let us start from protection and control. Over the years, we have experimented with so many different types of insulations. When it comes to circuit breakers, there is a huge variety of different types of circuit breakers. There are vacuum breakers, there are air circuit breakers, SF6 breakers, and now more environmentally friendly gases that are being used for extinguishing the arc. None of this would have been possible without research into materials, into chemicals, testing, lab work, R&D. The general trend in the industry is to decrease the footprint of electrical equipment and make the equipment lighter, more robust, and durable. We need folks who are doing research and development, are working in the labs, and also in the field. I've had students in my program who've had PhDs in electrical engineering, and some of them work in very specialized fields within power systems, where they're actively involved in research and development of different types of materials. Even if you look at distribution lines, distribution poles, transmission towers, the type of installations that we use on these lines has drastically changed over the last 10, 15, 20 years. You can see all different types of insulation in the form of polymers, ceramics, glass, and it keeps on evolving because the power systems industry is demanding not only for cost-effective, smaller footprint solutions, but the hallmark of this industry is reliability. So a lot of testing needs to be done on items that are produced by lab. And before they're adopted commercially, there are standards that need to be written. Think of it like research being done in the pharmaceutical industry, where they are always experimenting with new drugs in order to cure a problem. So once a drug is developed, they need to do testing on it. They run studies on different sample sizes of folks. Sometimes these are experimental drugs. They monitor the patients for different types of symptoms. And then they have to demonstrate to FDA that the improvement that we are seeing in the patients is actually more than just a placebo effect. Placebo is an interesting concept, and I'm digressing a little bit, but it's like giving somebody a sugar candy and then telling them that it's actually a medicine which is going to cure the underlying disease or the symptom that they have. They take it as a medicine, and in so many cases, you can look it up, placebo itself is able to cure the underlying issue. But one of the checks is that the pharmaceutical company, the team, the lab has to demonstrate that the impact on the patients is more than just the placebo. When a new material is being launched by R&D department of a particular company, then it needs to be tested. So who ensures what type of tests need to be done on the equipment? Because you cannot simply just take it and install it in the field. Now there are codes and standards that come into play. ANSI, IEEE, NEC. ANSI and IEEE typically write a lot of these standards. And then there's some specialized standards that are also written by other bodies such as NEMA. There are companies out there like Intertek and Underwriter Laboratory that actually hire electrical engineers to come up with the criteria of testing. As you can see, at every step of the way, electrical engineers, especially folks who have materials background or electrical engineers working in collaboration with materials engineers and chemical engineers, are coming into the scene. So now when you're developing these standards, you have to go about testing them and evaluating their performance. And that's not it, because now this particular innovation has to be commercialized. As you probably know, that not everything that is developed in the laboratory can be seamlessly transferred into mass production, into commerce. Now you go about launching this product in the market, you come up with the next line of transformer of motors, higher efficiency, smaller footprint, lower energy consumption, more reliability, durability. And from an end utilization standpoint, the customer who is now buying your motor, your transformer, your cable, your circuit breaker would want to test it again before they go about installing it. And they will have their in-house owners engineers. This is where electrical engineers are coming into play again. So you need to know, like a doctor, which tests you need to carry out on this particular equipment. Now you don't have to reinvent the wheel because, as I mentioned, some of these bodies, ANSI, IEEE, NEMA, already have standardized tests. But knowing which test to carry out is one thing, and actually testing it out in the field is something completely different. And even when you set up the test and carry out the test, how do you analyze what you're looking at? Within my PE Power exam preparation program, we go over a topic called installation testing. When it comes to installation testing, there are so many different types of tests. Within the context of PE Power exam, they only mention one test, which is the polarization index, but you have the the dielectric strength test, but you have so many other types of tests as well. You have the option to do spot readings. You can do the dielectric absorption ratio test. You can do a step voltage test. You can do dielectric discharge and many others. And then you also have to analyze the results. The test is going to give you a number within a range, just like your glucose level, just like your blood pressure, just like the chemistry of your blood work. So as an electrical engineer, you have to know what you're looking at. And conducting these tests is actually an integral part of commissioning and startup. You can have so many different variations as well. For instance, an insulation test that is conducted indoor in a damp environment is going to yield a very different result for the same insulation when it is carried out outdoors in a dry, sunny environment. So you have to take these factors into consideration, and in order to do that, you have to have the knowledge. And this is why research and development, innovation, lab testing, field testing is such an exciting role within power systems industry. If you like to analyze data, like to innovate, have specialized knowledge set, which typically requires a lot more academic background and training, then there are tons of opportunities for you in the power systems industry. If you're already working in this space, I really appreciate if you could provide your insights and feedback in the comment section of this video. And if you have any questions about it, feel free to type up your questions in the chat section. Thanks again for watching, and I look forward to seeing you in the next video. If you like this video, then please don't forget to subscribe to this channel. Feel free to ask me any questions in the comment section of this video below. You can find tons of success stories of my FE Electrical and PE Power students over here. And if you want to learn more about preparation of FE Electrical and Computer exam and the PE Power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.